funds to buy domestic goods. They want to come in, and these people supply domestic funds because they want to go out and buy assets. Can you see that? So effectively, this graph is representing supply and demand for domestic funds in exchange market. Okay, so don't forget that supply and demand concept in order to see how it affects our life in future shocks and policies. Okay, let's practice a little bit more. Okay, remember? So, equilibrium real exchange rate is when these two are equal. This is what economy wants. Net export must be equal to net capital outflow. But suppose exchange rate, real exchange rate, is here. It's not equilibrium. So what's going on here? Suppose currently exchange rate is not equilibrium, is epsilon 1. Okay? So does anybody know what's going on at epsilon 1? Epsilon 1, you see? At this level, supply of funds, supply of domestic funds is this much. Demand for domestic funds is this much. Do you see that? So there is excess supply of domestic funds. When you have excess supply of domestic funds, it means what? Domestic funds become cheaper, okay? Less valuable. So let me write it here. So there is it here. Supply of funds, this is supply of funds is greater than demand for funds. So excess supply of domestic funds. So that means domestic funds become less valuable. Okay, depreciation, real depreciation, real depreciation. You see, therefore, real depreciation means what? Epsilon start going down towards equilibrium, towards equilibrium. But how do I know what happens to net export? See, net export currently is here. This is net export currently. But how does net export? Net export has to go up. But how does net export go up? Because of this. Real depreciation means what? Domestic goods become cheaper. Remember that? You have to practice that concept. So that means really domestic goods are relatively cheaper, or you can say foreign goods are relatively more expensive. Okay? So what does that mean? It means export goes up, import goes down. Is that right? So therefore, net export is rising. So you see, we are moving towards the right point. Net export is rising, depreciation is happening, so you are moving to equilibrium. You see that? This is how exchange market makes sure these two are equal. Net capital outflow and net export, they are equal. Actually, other way around, it should be very obvious to you, okay? But just for the sake of completeness, let me write that down, write that down too, okay? So suppose economy currently domestic real exchange rate is here, epsilon 2, which is not equilibrium. So what's going on over there? You see here, at this exchange rate, so demand for domestic funds by foreigners is more than supply of funds supplied by domestic people who want to go out and buy foreign assets. Can you see that? So there is excess demand for domestic funds. Excess demand for domestic funds. Look at here. So this is supply of funds. This is demand for funds. domestic font. Okay, so there is excess demand for domestic fonts. So what happens? When there is excess demand for something, that thing becomes more valuable, more expensive. Is that right? So it means domestic fonts become more valuable. So it means what? It means real appreciation happens. Real appreciation happens. Do you see that? So we are moving this way from real exchange point of view. But what happens to net export? Well, look at here. At this point, which this point is not an equilibrium, net export is too high. Okay? So how does net export move? Okay, that's very easy, because real appreciation means what? Make sure, this is very essential, don't get it wrong, I am talking about final exam now, okay? This is very important because this is something that people mess up generally in final exam. So, real appreciation means domestic goods become more expensive and foreign goods become cheaper, is that right? So, when domestic goods become more expensive or are more expensive, so export goes down, relatively more expensive domestic goods. Export goes down, import goes up, so net export goes where? Down. So it means you are moving this direction from net export point of view, you are moving this way in real exchange rate point of view, and you are moving towards right point. Can you see that here? So your move is correct. Do you see that? So that is the job of real exchange rate, to maintain equality, and how it maintains this equality. Can you see it here? By adjusting net export and net capital outflow. Yes, everyone? Okay, that is the model. That's it. So as usual, when we develop a model, we do exercises. This is what is important for test, exam, because this chapter will be covered by final exam, but that's a good idea for tomorrow test. So make sure you understand exercises in the notes, okay, and in the tutorial questions, okay? Okay. So, for example, you know that for fiscal policies, my favorite policy is expansionary fiscal policy. G goes up, but guys, please go home and practice what? When I told you almost every class, when I exercise G goes up, make sure you go home, G goes down, T goes up, T goes down, okay? Practice those. Similar, same thing. Is that right? So, very important. Don't forget that. Okay, so G goes up, and exactly what you need to do tomorrow, I ask you to draw the graph. Anyone? If G goes up, what happens to this structure? Does it have impact on demand for funds or supply of funds? Anyone? Yeah? Supply of funds, okay. How? Exactly. So from graphical point of view, exactly. So generally in one question, I asked you to draw the graph for me. Yeah, he's right. He's 100% right. Okay, so exactly as he said, look at here. Public saving goes down, but private saving, exactly as he said, stays the same. So national saving goes down. National saving goes down. By the way, investment is fixed. Is that right? Investment is fixed. Therefore, you have lower net capital outflow. Net capital outflow. Okay. So, what will the outcome of this policy? So we expect what? We expect real appreciation. Real appreciation, and we expect what? Lower net export. Lower net export. Okay, that's the graph, but you see, the point here is, this is what I expected tomorrow, of course, under different chapters. So, you see, obviously the graph shows appreciation, real appreciation, and net export falling down. Is that right? But then I am going to ask you, explain, remember, in step by step. So, guys, tomorrow, when you write down the step-by-step answer, don't miss any step. Don't jump. All right? I need the whole list. Okay? So, for example, here, forget about the graph. How do I know real appreciation happens and net export falls? Okay? How should I start here? Of course, he mentioned that part of it. Okay? So, you was up. You said what? You said. Exactly. Public saving falls. National saving falls because private saving is lower, and also investment is fixed. Is that right? Here, investment is fixed. So, but don't forget that. So this means what? National saving, fixed national saving. Lower national saving and fixed investment, that means net capital outflow falls. But net capital outflow is what? Supply of funds. So net capital outflow falls, but net capital outflow means, see this one. It means S minus I. S minus I. This falls. But as just previous slide, this means what? Supply of domestic currency funds falls. But you know that when supply of something falls, that thing becomes more valuable. So what does that mean? So it means domestic funds become more valuable or real appreciation. Real appreciation. Is that right? You see? So, you should not say, why real appreciation? You cannot say, because of the graph. Okay? Of course, graph matters, but you should be able to answer that. Okay, we answered that. So, real appreciation is happening. So, we go this direction. We explain this part. Okay? But how about this part? Net export. Okay, then we keep going ahead. So real appreciation means what? Real appreciation means domestic goods are more expensive. Is that right? So domestic goods are more expensive. Foreign goods are relatively cheaper. So that means export falls, import rises. So export falls and import rises. So that means net export falls. You see, we explain this. We explain this and we explain this. Tomorrow, guys, please don't do something which has been the most popular mistake when you are writing down the explanation. As people in this part, people try to start try to explain graph again. You say, okay, this curve shifts to the left. No. This is stand-alone. It's independent. Can you see that? It's by itself, a separate part. Okay? Because actually sometimes I ask directly, explain the shifts. That's yeah. You can explain why we have shifts like that. Okay. But if I ask you step by step explanation, don't explain the graph again, because the graders deduct mark. Okay. This is exactly what we need. Okay. Of course, under the context of previous chapters. Okay, that was one exercise. Let's do another exercise. Okay? How about this one? Remember, foreign interest rate is exogenous. Remember, assumption. One assumption behind small open economies is domestic interest rate is equal to foreign. So it means what? Domestic country cannot affect world interest rate. So it's exogenous. But suppose foreign interest rate goes up. Foreign interest rate goes up. What happens? Part A, graph. Anyone? Anyone? Graph. No answer. What happens? So when foreign interest rate goes up, how does that affect my economy? Yes? Yeah, but how does it change? That's it. Because it's very easy. Actually, make sure when you draw the graph for tomorrow, graphs must be what? Please draw nice graphs with all the labels and formulas. You see? Make sure you do that, okay? To get full mark. Okay, actually, you see, having those relations helped me to see the impacts. So, can you check here? Here, the real exchange rate, foreign interest rate has only one impact. There is nothing else. As she said, investment. Exactly as she said, negatively. So when domestic interest rate goes up, investment goes down. But look at that, national saving, S is fixed, investment, as she said, goes down. So net capital outflow goes up. Okay, so from graphical point of view, when net capital outflow rises, so it means, remember, net capital outflow rises, so this shifts to the right. And what do we expect? Based on graph only, we expect real depreciation, and we expect what? We need higher net export. New equilibrium point in the exchange market predicts higher net export and lower or real depreciation, lower exchange rate. Okay? Okay, that was from graph point of view. But how does that work in terms of explanation? Okay? So, how should we start, guys, here? So, see? Investment falls, exactly as you guys said. Investment falls. But national saving is fixed. Is that right? So it means what? People want to go out and invest abroad more. Actually, it's very obvious. You see, when foreign interest rate goes up, so it means what? It means abroad, people get more return. Is that right? So that encourages people to go out and invest abroad or buy foreign assets. Okay? So investment falls, national saving is fixed. So this means what? Net capital outflow rises. Net capital outflow rises. But be careful. Net capital outflow is demand for supply of funds, domestic funds, because people want bring more domestic funds to get foreign funds to go out. Is that right? So supply of domestic funds goes up. Supply of domestic funds goes up. So it means what? Domestic funds become less valuable. Okay, less valuable. So that means real depreciation. Remember, real depreciation was exchange rate between exchange between goods in terms of goods. Here, everything is real. So real depreciation. So we explained this. We explained this part. Okay, how do we get to this part? That should be easy. Real depreciation. Real depreciation. That means domestic goods are cheaper, foreign goods are more expensive relatively. That means export rises, import falls, therefore net export rises. Do you see that? So this is how things are happening in exchange market. So exchange market always maintains net capital outflow equal to net export. Okay. Okay, that is everything about real exchange rate. So this is how real exchange rate is determined and the job of a real exchange rate. Real exchange rate has responsibility to maintain net export and net capital outflow equality. Okay, but if you go back to the first part of this chapter, we also introduced something called nominal exchange rate. Nominal exchange rate is the one that you find in banks. Okay, you can go to a bank and I guess I repeat this several times in this class that in real life, nominal variables are observable. So in real life, you are signing nominal wage contract with your employer. Okay, banks are working with nominal interest rate. And if you go to a bank and ask for exchange rate, they are giving you nominal exchange rate. But from economic point of view, real variables are important. Unfortunately, real variables which are important, real wage matters. The purchase power of your wage matters. It doesn't matter how much dollar they pay you, okay? So, the same thing, real exchange rate matters. But if you go to a bank and ask for real exchange rate, nobody can give you none. So that's a problem. We talked about that, problems with inflation rate. Inflation, what's wrong with inflation? Why we hate inflation? Because it distorts the relationship between real variables and nominal variables. Because we sign all our contracts based on nominal variables, but real variables are important for us. And the difference is always going back to prices, okay? So, you remember, we derived relationship between real and nominal exchange rate. Remember that? Real exchange rate, nominal exchange rate. And real exchange rate, you see, it's just price ratio. We talked about this. Price ratio for goods between domestic goods and foreign goods, okay, expressing in terms of what? One currency. One currency. This is price of, remember we talked about Big Mac. Big Mac in Canada, Big Mac in Japan, okay? So this was what? Price of Big Mac in Japan. This was price of Big Mac in Canada, but they are not comparable now. So we used what? Nominal exchange rate to make them comparable. Okay, we found this, okay? Now, we are talking about how nominal exchange rate is determined in the long run. I repeat again. In short run, completely different story. That we talk about that in a different chapter. So let me solve it for nominal exchange rate. This is nominal exchange rate relation. And the other thing that I almost repeat every class is what? Levels don't make that much sense in us, okay? Growth rates, we are working with growth rates. Growth rates make more sense in economics, okay? So, and I told you how to change a relationship in terms of multiplication and division of levels of variables into what? Addition or subtraction of growth rates of variables. Okay, we talked about this before. Okay, so you can write this as this. Can you see it here? So I told you to prove you can take logarithm of both sides and then differentiate both sides. Okay, then you get this. You get this. Okay, see everything growth rate. Growth rate of E equal to growth rate of epsilon plus, so multiplication means plus growth rate of foreign prices, and division means subtraction, minus growth rate of domestic prices. Okay, actually this is very familiar to us. I mean, those two terms. So this is in foreign inflation rate. You know that? Growth rate of price index is inflation rate. This is inflation rate in foreign country. This is inflation rate in domestic country. So let me introduce each of these terms. So this is nominal depreciation rate because everything is in terms of percentage. Percentage. Right? So, nominal depreciation rate, this is real depreciation rate, and I told you how epsilon is calculated, is found in the economy. Remember? Exchange market. Equality of net export and net capital outflow. Okay, so we know this, how this part is determined. So this part is coming from exchange market, just previous slide. Previous slide. And what is this? This is called inflation differential, the difference between foreign inflation rate and domestic inflation rate. Domestic inflation rate. Okay. Where does this inflation differential come from? Now, you remember chapter, what's it, chapter 5? 4 or 5? So you remember, in long run, inflation rate is equal to growth rate of money supply. So, growth rate of money supply. So, essentially, these two are determined by monetary policies. In foreign country, monetary policies in domestic country. Okay? So, as you can see, exchange rate, nominal exchange rate is determined by real exchange rate coming from real side of economy. So, and monetary policies in this country and in foreign country. Yes, everyone? Now, let's do what I call a kindergarten example. So, suppose real exchange rate is fixed. Suppose the real exchange rate is fixed. And foreign inflation rate is for 6%. And central bank of domestic country is increasing money supply 3% per year. 3% per year. Okay? Now, we want to know what happens to nominal exchange rate. Nominal exchange rate. So, nominal exchange rate. So, first, what is domestic inflation rate? Domestic inflation rate, based on that chapter, is equal to growth rate of money supply, so 3%. So this is 0, this is 6%, and this is 3%. So as you can see, we are having, you see, in general, we call this ratio depreciation rate. But its actual name, it goes back to its sign. See, here, depreciation rate is positive. So that means what? It's in fact appreciation. Remember? So for example, we call negative inflation, in fact is deflation. Okay? In general, we call it inflation. Okay? But actually it depends on if you have positive inflation or negative inflation. Negative inflation is called deflation. The same thing. We call this depreciation rate, but when it turns out to be positive, it means what? It means nominal exchange rate is going up. Nominal exchange rate is going up, which is in fact appreciation. So this country is facing with 3% appreciation per year. What does that mean? It means the currency of this country is strengthening, becoming stronger 3% per year compared to the foreign currency. Okay? So nominal exchange rate specifically is affected by two things. Number one, anything which is coming from real side changing real exchange rate, so that goes back to this. You see, for example, something real, like real interest rate is changing, or fiscal policies, is that right? So fiscal policies and any real change affects epsilon, okay? So this is what I was. Can you see that this part is coming from exchange market, real side of economy. And then, so this part, so fiscal policies affect this part. Monetary policies affect this part. Can you see that? So the nominal side is affected by monetary policies. Monetary policies. Okay, so we did this exercise. So in fact, this is representing an empirical study. An empirical study showing correlation between depreciation rate of exchange rate, nominal exchange rate, versus inflation differential. So as you can see, here you have different countries with respect to United States. United States, so each country's inflation rate minus, compared to US inflation rate. So for all these countries, US is the reference point. Inflation differential, but as you can see, correlation is very strong, okay? So 85% correlation, okay? 85% is very strong. Why? Why not stronger than that? Because, don't forget that, the model that I presented to you is good only for long run. And in empirical studies, you cannot, because you are using actual observation, you cannot separate short run, long run. Is that right? You cannot separate short run, long run. Therefore, there are some deviations from long run results. Okay. Okay, let's talk about this part. This part may not be in your textbook, but it's very important. Unfortunately, your textbook misses this part, which is very important for the long run analysis. Okay, you see, there is something called the law of one price. Remember, in the beginning of this chapter, I talked about Big Mac in Japan, Big Mac in Canada. Is that right? And there was a difference between prices. In my example, you remember real exchange rate? I got what? I got 1.2 what? Japanese Big Mac per one Canadian Big Mac. Is that right? But there is a question here. Why a Big Mac, which is same good, okay? I use the Big Mac because Big Mac is very standard product. Okay? So, should Big Mac have the same price everywhere? Well, why? So, the law of one price says each good should have the same price everywhere if you express the price in terms of the same currency. And we did it in terms of the same currency. Please go back to your notes. So we expressed everything in the same currency. So we got what? 1.2 Canadian, Japanese Big Mac per Canadian Big Mac. Okay? So what is this? Is it possible? Okay. So the law of one price says one good must have the same price everywhere if it is expressed in terms of the same currency. Okay. Of course, there is a very, very big if here. This if is kind of big. Okay. So what is that if? So first of all, markets must be perfectly competitive. Market for Big Mac, for example, must be competitive. Number two, there should not be any transportation cost. Okay, because you know, some places could be very close to production site, some are far. Okay. Number three, no official barriers to trade. It means what? Your tariffs, quotas that these days very controversial. So taxes, government policies. Different countries have different taxes, different sales tax. Is that right? So in Canada we have a whole lot of more taxes. So this is true if you don't have those barriers, so-called. So each good must have the same price everywhere. Okay. For example, imagine a commodity like wheat. Okay. We use commodity because commodity is similar. Wheat is wheat. Is that right? So suppose exchange rate between Canadian dollar and British pound is this $2 per pound. Okay. But a bushel of wheat in the UK is 1.5 pounds, and in Canada is $1.5. As you can see, this story doesn't make sense. Is that right? Because as you can see, it looks like wheat is more expensive in the UK versus wheat in Canada. Can you check here? So the law of what price says there would be arbitrage. Is that right? If there is a discrepancy between prices here and there, so there is a pressure from arbitrage because people want to buy from cheaper place and sell it in more expensive place. Okay, so here there would be a pressure, arbitrage pressure with the cheaper in Canada. So people try to buy wheat in Canada and export it to UK. Is that right? So arbitrage. Arbitrage is the backbone of finance, is that right? So this is the pressure that brings equilibrium to the markets, okay? Because people would take advantage of any profitable opportunities. So if this is the case, nominal exchange rate, price of wheat in UK and price of wheat in Canada, you can make a profit out of that, okay? So, however, that pressure brings everything to equilibrium. So higher demand for wheat in Canada and higher supply in UK. But look at here, what's going on here? Because everybody is trying to buy wheat in Canada, so demand for Canadian dollar goes up. Is that right? Demand for Canadian dollar goes up because demand in Canada is high. They want to buy wheat in Canada, so they need Canadian dollar. So higher demand for Canadian dollar. So Canadian dollar appreciates because everybody wants to buy Canadian goods, dollar to buy Canadian goods. So Canadian dollar appreciates and British pound depreciates. So actually, you see, this is a possible equilibrium. $1 per pound. You see, it matches. It matches. Okay. And by the way, given that these two countries only produce wheat, for example. Okay. Okay. But this was only for one good. the law of one price. The more general version of the law of one price is this: purchase power parity theory. Purchase power parity theory is application of the law of one price to a basket of goods and services. To a basket of goods and services. It says what? It says a similar basket of goods must cost you the same amount everywhere. If you express the cost in terms of the same currency, okay? So purchase power parity theory is the application of the law of one price to a basket of goods. So see, again, assuming that you have arbitrage, okay, international arbitrage, all countries must have the same price levels when prices expressed in terms of the same currency. Or you can say if that requires a basket of goods must have the same cost everywhere, okay? Or you can express it in this way: the currencies of all countries should have the same purchasing power everywhere. Is that right? So purchase power of currencies must be the same. Is that right? Because every basket of goods must cost you the same amount everywhere. Okay? So now, what does that mean? What does that imply? It implies this. Okay, this part is what we have done before, net export vertical. Now this part is new. So if this is true, if the law of one price, if purchase power parity theory holds, real exchange rate must be 1. What does that mean? 1.2 Big Mac, Japanese Big Mac per one Canadian Big Mac? I mean, it doesn't make sense, okay? So there should be, because Big Mac is Big Mac. So if this is true, so real exchange rate must be 1, okay? Must be 1. Now, many years ago, when people talked about this, there was a huge wave of research that if this is true, if real exchange rate is fixed, essentially, okay? So see, this is true, it means what? It means, remember a few minutes, it means what? It means net export, your net export function, it means net export function is flat. It is not downward sloping. That's the implication of real purchase power parity theory. Okay? And if this is true, you remember my exercises that I did? I changed real exchange rate, I changed G, okay? See here? And I had what? I had different real exchange rates. So if this is true, so it means changes in national saving, investment, capital outflow, net capital outflow has no impact on real exchange rate, and also no impact on nominal exchange rate, because the real exchange rate is fixed, nominal exchange rate is depending on only money supply, not fiscal policies, nothing in real side. Okay, so that's another implication. So changes in saving, investment, net capital outflow don't have any impact on nominal and real exchange rate. Okay, no change, no impact on real exchange rate, and no impact on nominal exchange rate, because nominal exchange rate is affected only by monetary policies, inflation, not fiscal policies. Okay. 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 This is what they said. Only nominal, only monetary policies change prices and change nominal exchange rate. No impact on. Okay. So let's see more implications of purchasing power parity theory. Okay. So you remember this is the relationship that we found for real exchange rate. Okay. Now, based on this theory, that is 1. If this is 1, what does that mean? It means what I just told you a few seconds ago. Cost of a basket of goods and services must be the same everywhere across the board. Look at here. What is P star? P star is cost of a basket of goods in foreign country. Remember, P star we use GDP deflator, kind of, okay? So that is the cost of what, in fact? Basket of goods in foreign country. But in terms of foreign currency, this is in terms of foreign currency, okay? But what is this part? This is basket of goods in domestic country in terms of domestic currency. Domestic currency. Okay, now when I multiply this by E, real nominal exchange rate, so this would be what? This would be cost of a basket of domestic goods in terms of foreign currency. You see, now these two are comparable. You see? Foreign currency, foreign currency. This is the basket of goods in foreign goods, and this is basket of price of the basket of domestic goods, okay? So these two must be the same. So based on this theory, nominal exchange rate is adjusting itself. Make sure to what? Make sure making basket of goods, the same basket of goods, the same everywhere. That is how nominal exchange rate is determined. Be careful. Based on this theory. Okay, based on this theory. Okay, so that's why I am going to see. Imagine this. Let me calculate E here. So if this is 1, then nominal exchange rate would be foreign prices divided by domestic prices. Is that right? This one? Okay. Again, based on this theory, nominal exchange rate, make sure basket of goods is the same everywhere. Okay. So based on this theory, so that's why I call this purchasing power parity exchange rate. Purchasing power parity exchange rate. Okay. So we have 2 exchange rates here, guys. 2 nominal exchange rates. One is just E, nominal exchange rate, which is real exchange rate and prices here and there. Okay. And based on this, the nominal exchange rate is just price ratio. Just price ratio. So now I told you, from theory point of view, it makes sense. The law of one price and purchase power parity theory. But is this really true? Okay, so as it turned out, the purchase power parity is not one, it's not fixed, but its variation is small. Its variation is small. Why? Because in reality, small changes in the price differentials leads to big net export changes. Okay, so so deviation from, it's not fixed. However, its variations small. So big variation and long time deviation are rare. Okay? So it tells me net export function is not horizontal, however, it's not steep. It's very flat. Okay? Can you see it here? Very small deviation. Very small deviations lead to what? Big net exports, okay? Because of arbitrage, okay? That arbitrage works, okay? Profit-seeking agents. So, but the question here is, why it doesn't work perfectly, okay? And generally, it goes back to the assumptions. You know that I said if. So if, those ifs generally don't hold. Those ifs don't hold. So, number one, you ever, I used what? I used Big Mac. Big Mac is very standard product. In reality, products are not perfectly substitutable. For example, when we talk about cars, cars are not perfect substitutes. Some people prefer European cars, some people prefer Japanese cars. Is that right? So, from a utility point of view, there are preferences. Okay, so yeah, maybe you will use the commodities like wheat. Okay, but commodities are very standard. But most of other goods are not that standard. Okay, so number two, imperfect competition. Now I don't know if you remember your microeconomics. So even in one country, if a firm has market power, that firm can apply lower price discrimination. Price discrimination. So you have a third degree price discrimination. So you can charge different people differently. Okay. So you can charge. Have you seen that? The movie theaters. They have adult movies, and then you have cheaper tickets for kids and senior citizens. Of course, that is not for out of soft heart, okay? They don't care about it. Okay, it's just profitable. And in macroeconomics, they prove that. Okay, so imperfect competition. Have you seen that? Everything is more expensive in Canada. Even considering the exchange rate, still more expensive. So, for example, even iPhone. I mean, iPhone products. You know, iPhone products are very standard products, but their prices are different in different countries. So I don't know. But there was a time. What was it? I forgot. iPhone 15, 16. I don't know, because my iPhone is still iPhone 8, 9, something like that. I am pretty behind. So my friend in UK said if I buy a round trip ticket to US, buy here US and come back, it's still cheaper. Okay, so imperfect competition, and all sorts of government policies. Different countries have different tax structure. Is that right? And also trade barriers, quotas, tariffs. Actually, this is a time that I don't need to tell you about that, okay, because you hear about that in news. Is that right? So that makes goods prices differently. But possibly, if you ask me, the most important one is this one. Okay? You remember we talked about what? We talked about transportation cost. Transportation cost for some goods is so large that make them non-tradable. What are non-tradable goods? Because there is no possibility of transportation or very expensive. Okay, for example, have you seen that? A housing sector. You cannot import like land. Okay, so price of land makes a big difference in housing prices in different countries. Is that right? Or services. Because services are not tradable. Okay, you have to locally provide services, and price of services are very different in different countries. Okay, so actually, let's take a break now, and then we finish this part. So please come back 10:41. Yeah, for this one. Yeah, 2 rows, and then we need to find total, and then based on these total, which is the same as here, then we can write this. Next one. Yeah, it's not all the numbers. And then after that. Yeah, exactly. Okay. We divide this by that, find this number, and then. No, just because otherwise we will. Exactly. Yeah. Okay. Yeah. That's exactly. Okay. Before. Yeah, you can take pictures. Sure. No. Just because I gave you this structure. Yeah. I leave multiple choice questions for quizzes. Yeah, that's that. Yeah, and numerical exercises, and also there would be questions about the definitions, concepts, short answers. Yeah. There is no multiple choice question. However, maybe some of the concepts would be there. Yeah. So, but there is no multiple choice question. So you have to write like short answers and exercise like this and numerical exercises. Yeah. So why purchasing power parity theory doesn't hold in reality, even though it makes sense? All right. So I told you several cases. So imperfect substitutability, imperfect competition, government policies, trade barriers, and this one, non-tradable goods. Okay. So you remember when we were talking about chapter 2, structure of consumption, we talked about C, private consumption is including durable goods, non-durable goods, and services. As services generally have a big chunk of consumption basket, all right? And services are not generally tradable, okay? So actually that brings us to a very important result that you have to be very careful in your calculations in future. There is a phenomenon which is called the Blasa and Samuelson effect. Okay, Blasa and Samuelson, two Nobel Prize-winning economists. You see, they said this. They said as we discussed, non-tradables are a big chunk of consumption basket. And these people said non-services, non-tradables are cheaper in, for example, developing countries compared to developed countries. Okay, so for example, they talked about haircut. The price of a haircut in Toronto, you can live one whole year back home in my country. so expensive compared to those countries. So in those countries, we have very cheap services. Okay, you know that traditionally, I don't know about your friends, but my fellow countrymates, what they do is they over the year they make a list of all, for example, teeth work that they need, or even beauty surgeries. Is that right? And then during summer, all of them go there and do 25 surgeries altogether and come back a different person. But if you want to do it here, you have to pay like thousands of dollars. But over there it's so cheap in terms of percent. Okay, so you see what happens? Remember, we talked about purchase power parity exchange rate. Purchase power parity exchange rate is this. You remember that? Assuming that epsilon is 1. Okay, purchase power parity theory. Okay, so you see, then those countries have a cheaper non-tradables. So you remember P, what is P? This is an aggregate price. Aggregate price would be lower. When aggregate price would be lower, so it means purchase power parity exchange rate is higher than nominal exchange rate. Nominal exchange rate is the exchange rate that you are seeing in the bank. In a bank, so they report this exchange rate. Is that right? But this is mostly affected by tradables, not non-tradables. All right. So if you include impact of non-tradables, exchange rate is nominal exchange rate is this one. Okay. So as you can see, developing countries, in fact, in developing countries, exchange rate is stronger. Can you see that? Can you tell it here? So stronger than what market tells you. Okay. So what's the implication of that? Implication of that is in developing countries, currencies are have higher purchase power. So that's why if you want to translate any domestic index of each country, any country to US dollar, so you should not use nominal exchange rate from the market. You have to always use what? Purchase power parity exchange rate. This has been very popular mistake among the students. Last year for CO6, I asked them to do like a term paper, and that was involved with changing GDP of countries, real GDP of countries, from local currency to US dollar currency. Okay, so many people used what? Nominal exchange rate from the market. Okay, which is not correct because GDP is including tradables and non-tradables. You have to use purchase power parity exchange rate if you want to do any economic measure from domestic currency to US dollar, whatever. So you have to use purchase power parity exchange rate. Okay, look at here. So for example, this is real GDP in terms of local currency, and you want to change it to the same real GDP in terms of US dollar. Okay, so you have to do what? You have to use exchange rate between local currency and dollar. Is that right? So you see here, this one. Now, which one do you use? So you have to use purchase power parity exchange rate, which means, remember I told you, purchase power parity exchange rate is larger than nominal exchange rate. So that means developing countries' GDP in terms of US dollar is more than what you think. Okay? So after all, the poorer countries are richer than they look initially. Is that right? So that is the idea. So please don't make that mistake. This is a very common mistake because nominal exchange rate, this nominal exchange rate is generally representing flow of tradable goods. The word net export, tradable goods, not non-tradables. However, the currency of countries are used for everything. Okay? So actually, this is very interesting. This is the list of GDP of countries in terms of US dollar, but once we used nominal exchange rate from the market, and this is what we use for using purchase power parity exchange rate, this one. Can you see it here? So, if you look at this ranking versus this ranking, as you can see here, developed countries or countries with expensive services are going down, and countries with lower non-tradables go up. Okay. For example, look at here. So here, for example, Japan, see, goes a little bit lower. China goes a little bit higher. Okay. Germany goes higher. But look at that. France goes down a lot. So it's clearly non-tradables in France are higher. Okay. Are more expensive. Okay. So for example, look at here, Russia. So you see it goes higher. Non-tradables are cheaper there compared to the advanced countries. Okay. Italy lower. Spain lower. Canada goes out of the table. And this is interesting. India. Look at India. India goes here. Yes, yeah? And that is obviously because of what? Because of undervaluation of India's currency, because non-tradables apparently are cheaper in India compared to, for example, US. Everything is compared to US because we are using US dollar. So as you can see, in fact, the developing countries have higher income as they may look initially, because purchase power of their currencies is higher. They can buy non-tradables cheaper in their own country. Okay, the last thing that I need to add before we finish this part is large open economies. So in this course, so far, we talked about two extreme models. One model for closed economies, over up to chapter 5. Chapter 6, small open economies, two extreme. Now you may ask me, how can we analyze large open economies, like the United States? Okay, so in fact, there is no model, explicit model for large open economies. But what I can tell you is large open economies are falling between closed economies and open economies results, okay? Now, the larger the economy, it would be closer to closed economies. Okay, for example, US is pretty much closed economy. If your analysis doesn't your analysis are not that different. Okay, so in fact, did I mention that once? When I was your age and I took my first macro course, amazingly, there was no open economy at that time. Macroeconomics, there was no open economy model. Okay, so in the introduction of the book, it said because foreign sector is very small in US from American writers. They said, oh, we ignore it. Okay, and this model and more advanced model in short run, and we're going to talk about that, was created by whom? Actually, you can guess. A Canadian. A Canadian created macroeconomics for open economies, and he won Nobel Prize for that. So, because for Canada, possibly they couldn't make that assumption, because for Canada, foreign sector is large. Is that right? So the bigger the economy, closer to closed economy. So a large open economy is between two results. Okay. So as I wrote, a mixture. Let me give you just one example. So you remember we worked G risers. This example, increase in G, for example, expansion fiscal policy. Okay, so please double check this. This morning that we did that for small open economies, and also compare it when you are getting ready for test for closed economies. Okay, so these two examples. So you should see this. National your G goes up, public saving goes down, national saving goes down. Okay, so now what happened? Please double check with example exercise in chapter 4 or 5, I forgot, and the chapter this morning. So interest rate, closed economy rises. Check with your previous chapters of your notes. A small open economy, no change. You want that this morning? Or the start fixed? Okay. So closed economy rises, a small open economy, no change. So for large open economy is what? It's rises. Between no change and rises, it would be rises, but that's the trick. Not as much as closed economy. Can you see that? So from value point of view, rises, but not as much in closed economy. So investment, of course, interest rate doesn't change, investment doesn't change. So interest rate rises, closed economy, investment falls, so you can guess. So in large open economy, so investment falls, but not as much as this. Okay? So falls, but not as much as closed economy. Net export, this morning we showed this. Net export falls. Small open economy. For closed economy, of course, that means net export doesn't change, because it's meaningless. So what is implication of that for large open economy? It falls, but not as much as small open economy. So falls, but not as much as in small open economy. Can you see that? Somewhere in between. Okay. So here I have it for US from numbers point of view. Okay. So as you can see, 70s, 80s. So as you can see, G minus T. So you can reduce T, increase G, it doesn't matter. Any combination. So as you can see, it has gone from 2.2%, everything is in terms of percent of GDP. So from 2.2% of GDP to 3.9% of GDP. So did you see that? Increasing. So closed economy, saving, national saving falls. Small open economy, national saving falls. In practice, it did fall. Okay. So interest rate, remember? Small open economy, no change. Closed economy rises. Actually, it did go up. Okay, from 1.1% to 6.3%. So investment, no change in small open economy. So closed economy falls. So it did fall. So can you see it here? So net export, closed economy, no change. Small open economy does change. Actually, it did change. Okay, it did fall. Okay, it did fall. So real exchange rate in closed economy is meaningless. So in small open economy, it rises. And in US case, yes, it did rise. Can you see it here? So actually the idea is this. Is that right? So it's a combination, a mixture of small open economy and closed economy. So this is the plan for large open economy that you have to take care of it yourself. Okay, that was chapter 6. So, any question, chapter 6? Because, okay, actually this is the end of also long run equilibrium. So from here, we start going towards short run equilibrium. So in order to go towards short run equilibrium, let me go over chapter 10, okay? I have already gone through majority of that, okay? So, but remember, chapter 10 is about the difference between short run, long run, and very long run. Short run, long run, very long run. But because it was so crucial, I discussed part of it before, okay? But let me finish it today, and then we start chapter 11, which is actually short run. Actually, short run. Okay, so chapter 10. Actually, I am not going over detailed slides of the slides that I did. Okay, but I just show you as a recall. Okay, so I went through these details in the past. So first I showed you in short run, generally we are focusing on fluctuations. Okay, cover business cycles. So as you can see here, economies are moving continuously. Okay, so as you can see economies go to recessions. So as you can see, real GDP, consumption, other variables, investment, everything is going up and down, and corresponding to the same time, so unemployment is rising. Unemployment is rising. Can you see that? So here we are going towards explaining fluctuations, cycles, business cycles. Okay, and there is something called Ocon's law. So in CO6, they talk about that and use that a lot. Okay. So the concept is very easy, and the relationship is called Occam's law, which is an empirical result. It's not a theory. And this theory, and the idea here is there is a negative correlation between, actually, did you see that here? There is negative correlation between output and unemployment. You see here? When output is falling, output is rising. So, sorry. When output is falling, unemployment is rising. Okay? That makes sense. That makes sense. Unemployment and output have negative correlation. If you produce more, unemployment would be lower. Is that right? Okay. However, from relationship point of view, this is something that we call Occam's law. So for this course, again, in CO6, they will talk about that more, but from this course point of view, having a negative correlation between output and unemployment is enough, okay? But this person used actual observations, empirical study, okay, found the better relationship between these two. As it turned out, relationship between output and unemployment is not that good, so this is better. You see, he said if we find a relationship between change in unemployment rate, is it here? Change in unemployment rate versus growth rate of output. Growth rate of output versus change in unemployment rate. Okay? So he found a better explaining relation. Can you see that? So as you can see, essential thing here is negative correlation. Negative correlation. Okay, so just for this course, just remember that output and unemployment have negative correlation. Okay, remember, this is in fact what I wanted you to know. What short run, what long run, and what very long run is. Okay, so economy is growing over time. Economy is growing over time. Okay, can you see that? So you can see two things. Number one, the trend. Number two, cycles. Okay, so the trend is representing full employment. Remember by bar? Full employment. Output level. So you got 5 names. You have to remember these 5 names. Potential output, output capacity, full employment output, natural level of output. Unfortunately, there is no agreement among economists how to call it. Okay, long run output level. Okay, this is reality. Okay, so from modeling point of view, we break down this in 3 pieces. So one piece, remember, starting from beginning of this course, and in fact, a couple of more classes, we are going to assume that output is fixed. Sorry, output capacity is fixed. Full employment output is fixed. Remember, capital fixed, labor fixed, technology fixed. Therefore, by bar, output capacity is fixed. Okay, this is what we have been the long-run model or classical view. We talked about this. Okay, we assume that the capital fixed, labor fixed, technology fixed, output is fixed, and we are going to be assuming that even in short run. In short run, capital fixed, labor fixed, and output is fixed. Okay, so and what we are going to do from now is short run model. Short run model. See, we will see how economy is deviating from long run output level. And in very long run, we forget about fluctuations, business cycles, and focus on the trend. And we are going to write down models about the trend. How economic capacity is changing. Okay, this is what we discussed. Again, recall this. Okay, remember I told you major difference between short run and long run is hinging on one thing, only one thing: behavior of price level. Behavior of price level. In short run, it looks like price is moving very slowly. So-called sticky. Okay. But in the long run, price is fully flexible. In the long run, price is fully flexible. Remember, I used this survey, okay, to show you why we believe in that. Remember, different firms change their prices at different frequency, okay. So, reasons for that, we talked about this, okay. And also, you remember in chapter 5, I wrote down a simple aggregate demand function, okay, based on quantity theory of money. Remember that? Of course, in chapter 11 and 12, we are going to construct a full-fledged aggregate demand function. Okay, it takes me 2 chapters. Okay, to construct aggregate demand here. But until now, remember, we used quantity theory of money to say that aggregate demand curve is downward sloping. Why? Remember, we talked about this. So suppose velocity of money is fixed. Suppose we don't touch money supply. Okay, then what? P times Y must be fixed. Okay, so P times Y, fixed number. So it would be what? So price would be MV over Y. Can you see that? So negative correlation. Negative, double sloping negative correlation. Okay, this is very easy version, chapter 5. This is what you need for midterm test, this much. Okay, from quantity theory point of view. Okay, so for now, until next chapter, let me stick to this. But I showed you, how does aggregate supply look like? Okay, so 2 versions. You ever recall? So in classical view, price is absolutely flexible such that aggregate demand is equal to full capacity. So output in this version, this is what we have been using so far. Price is so flexible, but output is fixed. Fixed capital, fixed labor, fixed technology, fixed output. Okay, so look at that. This means what? This means long run aggregate supply curve is vertical. Fixed output, price could be anything. Price could be anything. Okay, put aggregate demand curve on top of that. So point O is long run equilibrium. Okay, so this is the aggregate supply curve from long run point of view. Okay, and then so long run point of view. In short run, we are going to be Keynesian. In short run, we are going to be Keynesian, kind of super Keynesian, because Keynes said prices are sticky, but we are going to assume that prices are fixed, okay, at a predetermined level, okay, at a predetermined level. So price is fixed at a predetermined level, and firms sell as much as they can at that price. Can you see it here? So what does that mean? So short run aggregate supply curve is horizontal. Horizontal. Okay? Can you see that? So point O is equilibrium. Point O is the equilibrium. So if I put all these together, I have a downward sloping aggregate demand curve, a vertical long run aggregate supply curve, a horizontal short run aggregate supply curve. Okay, this is my structure. This is my structure. However, be careful. If you take CO6, over there, they tell you that short run aggregate supply curve is not horizontal. It's upward sloping. That is CO6. That is CO6. Okay? Remember, Keynes said sticky means prices are changing but slowly. So short run aggregate supply curve would be upward sloping, but that would be in CO6. For PO6, this course, we just, this is short run aggregate supply curve, this long run aggregate supply curve. That's it. And this is my aggregate demand curve. Is that right? That is the plan. That is the plan. Now, how do we deal with this? You have to be careful. Remember, I told you we start short run. Is that right? But we don't do only short run. We do two things. We analyze short run equilibrium, and then we analyze what? How do we go from short run equilibrium to long run equilibrium? Is that right? That is important because since the beginning of this course until now, you worked only what? Long run equilibrium. Is that right? But after all, when we talk about short run equilibrium, we have to go to long run equilibrium based on your past knowledge. Okay, so you need long run equilibrium knowledge that you have developed so far. That's why it's so important. Because when we talk about short run model, when we finish short run equilibrium, then we have to explain how we go to long run equilibrium. Now, how do we possibly this slide, which is new, you see, we didn't discuss it. This part is the only new part that we are going to talk about. Okay, this is the most important slide in chapter 10. Why it is so important? Because it shows us how we go from short run to long run equilibrium. Is that right? So when we finished short run equilibrium, at the end of each short run equilibrium, we use this table to go from short run equilibrium to long run equilibrium. Okay? Now, please don't ask me about this table because the reason behind this table is unfortunately in CO6. There's one whole chapter about why this is the case, okay? But, you know, that's why I feel more comfortable with long, year-long courses downtown. In downtown, micro, macro, we have long, year-long courses because we cover everything. But the reason behind this table, you need to take that course, okay? So, actually, I call this table prescription table, okay? So, you see guys, this is how we go from short run to long run. If in future, in next several chapters, in short run equilibrium, we end up with this. If actual output turns out to be above equilibrium output, is that right? So what happens to long run? Over time, from short run to long run, price gradually rises. Price gradually rises. Now, reasons are there, but to give you an idea, that's the idea. When you are producing more than capacity, remember 5 bar is your capacity. When you are producing more than capacity, it means what? It means you have excess demand for capital. You see, you are producing capital fixed, labor fixed, technology fixed. You are producing more than capacity. It means you have excess demand for capital, excess demand for labor. This is not sustainable because you don't have excess. So it means in long run, capital becomes more expensive, labor becomes more expensive, production cost goes up, price goes down. Can you see that? So price goes up, you go back to Y bar. That's the idea, rough idea, but in CO6 they talk about that in detail. So how about this? So guys, please don't forget this table. If your short run analysis ends up this, output is less than capacity. Now, two situations in future. If you are in recession or your economy is in stagflation. So you have this. So what happens? Price falls. Price falls. Can you see it here? Okay, price rises there, falls there. How about this one? If output is equal to Y bar. Okay, so that is longer equilibrium. All right, because output is exactly equal to output capacity. So price remains fixed. So this is equilibrium. Is that right? Okay, guys, yeah, I mean, don't forget this table. We need this for the rest of this course, okay? Now, for example, let me give you one example of application of this table. Be careful. We go through these details in chapter 11 and 12, two chapters, two big chapters, okay? But today, just make sure we remember that table. Let's do a little bit exercise. Suppose my economy is in equilibrium, long-run equilibrium. You see, point O is long-run equilibrium. When long-run aggregate supply curve, short-run aggregate supply curve, and aggregate demand curve, all three, when all three intercept each other, so that is long-run equilibrium. Is that right? So long-run equilibrium means what? Long-run equilibrium means if you don't touch economy, economy stays there. If you don't touch your economy stays there, okay? But if you hit your economy by a shock, a policy, so your economy goes where? Your economy first goes to a short-run equilibrium, then it goes to long-run equilibrium, okay? For example, imagine, suppose you apply, as you will see in future, an expansionary fiscal policy or monetary policy. It doesn't matter. Details future. But aggregate demand curve shifts to the right. Okay? So how we increase aggregate demand curve in future? But we increase aggregate demand curve, but you can tell by expansionary fiscal policy or monetary policy. Is that right? Okay. So that's what happens. So we go first to short-run equilibrium. Short-run equilibrium, you remember I told you what? I told you at predetermined price level, firms sell as much as they can. So in this case, they are selling this much. Tells you they can sell this much. So output, actual output is greater than capacity. Actual output is greater than capacity. So A is short-run equilibrium. Do you see that? Remember, short-run, your Keynesian. Price is fixed. So we go from O to A. But we gradually over time become what? Classical economists. Is that right? So your prescription said what? If output is above I bar, price over time gradually goes up. Let me write it here. So in the short run, Y equal Y bar, greater than Y bar, your economy is overheated, so price rises in the long run. So you see, this part is happening gradually. So price gradually goes up. See, like this. Okay, how far? This far. Okay, so let me do it nicely. Why economy stops there? Because at that point, output becomes equal to Y bar. See, all along from point A to point B, output is above Y bar, price keeps going up. But at Y equal Y bar, price stops. So economy stops at long run equilibrium. Is that right, everyone? Did you see that? This is what we do all the time in future. We go to a short run and then short run to the long run. So long run is about only one thing: price adjustment. That's it, price adjustment. Okay. How about this one? This case is very interesting. You see, sometimes shocks come from supply side. So your book calls them price shock. Okay, price shock is including what? Have you seen that in news? People are interested in price of oil. Why price of oil is so important? Because price of oil means price of energy. When price of energy goes up, so it means production cost goes up. Is that right? So anything like that, like price of oil is the most famous one. Okay? Or like bad weather, crop failure in agriculture sector. Okay? Or workers unionization. So you know that. So have you seen that? I mean, these days Amazon is not that cheap anymore, and Uber is not that cheap. Like you possibly don't remember early days, so they were amazingly cheap. But Uber workers and Amazon workers gradually what? They created union, and when they created union, I mean. Not everywhere. In US, some states, some even cities separately. Is that right? So it means what? When they create unions, then their wages go up, and also what happens is that they ask for benefits. Is that right? So insurance and things like that. So production cost goes up. Okay. Or environmental regulations. Saving environment is very good, but of course it comes at a cost. Is that right? There is no such a thing as free lunch in economy. Okay. So can I sit here? By the way, suppose Y bar doesn't change because it's not in your book, in the book that we are using downtown. So supply side shocks can change Y bar. But your push doesn't have that. Okay, suppose price of oil goes up. What happens? See, you have that predetermined price level, all of a sudden goes up. Short line agri supply here. This is supply side impact. Supply side impact, okay? So what happens then? As you can see, at this new price level, so firms can sell only this many units. You remember that? Firms try to sell as much as they can. So they sell that much. Okay? So let me write it here. Okay, short run equilibrium. Short run equilibrium. So what happens in long run? As you can see, in short run, output is less than capacity. So what happens in short run? In short run, your prescription price level start falling. Is that right? You remember that? Just prescription. So price falls. Yeah. Just go by that table. Students always forget. You see? Until when? Until we go back to point O. Is that right? So see. So prices go down. So we go back to point O. Point P is new long-run equilibrium. Did you see that? Here, if you have adverse, this is called an adverse supply shock, you see? So your economy goes to recession, is that right? Actually, this is stagflation. You have recession and kind of inflation. Inflation pressure, prices to go up. Is that right? So, you go to recession. Maybe you imagine how can government avoid recession. You see, suppose economy. You see, suppose government is so smart, can see everything, and government can see this shock. So if government doesn't do anything, we go to point A, and after that, prices have to fall. This price adjustment is so complex, painful, difficult. It takes time. Therefore, how can government avoid the recession? Anyone? Suppose government can see this shock, negative shock. So is there any way that government can prevent recession? And by that I mean keeping output at my bar. Anyone? What do you think? Is there any mechanism? Yes? Yeah, exactly. Exactly. Remember, I told you aggregate demand is chapter 11, future, chapter 12, a combination of fiscal policies, monetary policies. So yeah, government can increase aggregate demand. So let's see. So let me go to the next slide. So we call that policies like that stabilization policy. Stabilization policies are policies in order to keep economy at Y bar. Keep economy at Y bar. So making sure that economy doesn't go to recession. Okay? So for example, you remember this is adverse shock, and exactly as he said, you see, if government applies expansionary policies, so then look at that. You see here economy doesn't go to short run. Economy goes from point O to point B. But don't forget that at point B, because Y is equal to Y bar, you don't need price adjustment. Okay? So economy never goes to recession. Economy never goes to lose employment. So that is advantage. That is advantage. But what is disadvantage? Prices remain higher forever. Remember, in previous case, prices went back to P, but here prices remain higher at P prime. Okay. So, but again, in economics, you don't have a life. You never have a very large. You have to pay something. Okay. But the good thing here is employment remains at full employment. Output remains at full employment. Is that right? And you don't need a secondary price adjustment. You see, when the economy is adjusting from P to P prime, you don't need to go back to P again. Okay? So that is the advantage. Now, if you take CO6, then they are going to discuss what? They are going to discuss should we actively intervene in the economy and apply policies to stabilize the economy, because not all economists are in favor of stabilization policies. And the reason behind that, again, I don't want to teach CO6 here, but because, you see, first of all, you have to be very, remember I said, suppose government is very smart and government has a crystal ball and can see the shock, right time, because sometimes it takes time between the time that hits the shock hits the economy and you feel the shock, okay? So, so it means you always see the phenomena with a lag. So your decisions are based on something which has a lag, is behind. And some economists believe that that may cause more destabilization than stabilization. Okay, so if you take CO6 over there, they tell you if these policies can help or not. Okay, so that was chapter 10, refreshing, but the whole idea is that table. Make sure you don't miss that table. That table is so important. Okay, let me go over a little bit of chapter 11 just to start that. Okay, so chapter 11, officially we start short run. We officially start short run. By short run, I mean economic fluctuations, business cycles. Okay, business cycles. Okay, I told you how we don't touch aggregate supply curve in MGEB06. Okay, so horizontal short run aggregate supply curve, vertical long run aggregate supply curve. In CO6 they go further. They discuss the details. Okay, but we don't touch it here, so that's that. However, as I promise you, I am going to construct aggregate demand curve from scratch. Remember, chapter 5, I gave you just a rough idea, quantity theory of money, downward sloping, okay? But now, in chapter 11, we are going to construct aggregate demand curve carefully. Okay, guys, essentially we are going to do everything again. You remember that? Goods market, financial market, everything that we did in long run, we are going to repeat that in short run, okay? So now I go back to goods market and talk about supply and demand for goods, okay? So now, you remember, recall from chapter 2? So this is GDP from expenditure side, demand side, okay? So you remember, so private consumption, private investment, government spending, net export, okay? So let's talk about demand for goods. So demand for goods is coming from 4 sources, as we discussed in the past. Private consumption, okay, so still we are going to use the same concept that we had. Private consumption as a function of disposable income. Disposable income. Disposable income is total income minus taxes. And you know that from the past. Taxes are exogenous policy variables, nothing new. Nothing new here. Number 2, nothing new here either. So investment is negatively related to real interest rate. You know why? You know that? It's because investors can have 2 sources of funds for investment. Number 1, borrowing. Okay, so then interest rate would be cost of borrowing. So higher cost of borrowing means lower investment. Or investors may use their own resources. Is that right? Still, interest rate is opportunity cost of their own resources. Okay? So, okay, you know that. So that's why investment is negatively related to real interest rate. Okay, G is government spending, exogenous policy variable, okay, set by government. Nothing unusual. And net export, again, I go back to closed economy. So we are going to spend a few chapters, closed economy, and when we are good at closed economy, we talk about open economy. Open economy. Okay, okay. So now, this is what? This is planned expenditure. The sum of four forms of demand. Okay, so this is conceptual part and algebraic part. Okay, let's do graphical version. Okay, so you see, I put planned expenditure here. I put output / income here. Is that right? I am going to draw graphs for everything, assuming that government spending is fixed, government tax is fixed, price is fixed. Over. Now look at that. Short run. Be careful. Short run means what? Capital fixed, labor fixed, technology fixed, output capacity fixed, price fixed. Price fixed. Now, something amazing that I am going to do that I didn't do last time is this part. Suppose in goods market, here, I mean this part, real interest rate is fixed. Of course, it is not fixed, but I am going to correct that, okay? For goods market, suppose currently interest rate, real interest rate is fixed. And also be careful, this is goods market. Everything is in real term. So real C, real G, real output, real everything. Okay, you know that. Okay, so let's draw elements of demand. Okay, number one, G. Remember, G is a fixed number set by government. G is a fixed number set by government. Okay, guys, how does investment look like? Remember, investment is negatively related to interest rate. But interest rate is fixed. So it means what? So it means investment is fixed. Investment is fixed. Be careful. Investment is not fixed. Investment is a function of interest rate, but interest rate is given in this graph. Therefore, investment is fixed. Okay, so G, government spending, investment, and the only thing left over is consumption function. And consumption function is upward sloping because it's positively related to income, disposable income. Suppose T is fixed, so it becomes upward sloping with respect to Y. And the slope of consumption at any point is MPC. You remember that? Marginal propensity to consume. Okay? Now, how can I find planned expenditure, guys? Planned expenditure was what? Planned expenditure is C plus I plus G. Okay? So, how can I add these three things? So this is how you see, you have to add these three curves vertically. Okay? So how, look at here, for example, at this point, you have to add this much I, this much G, this much C. So it would be somewhere here. You have to repeat this here. Okay? So this much C, this much I, this much G. So it would be somewhere here. Okay? So So you have to do it for every point vertically. This is called vertical addition. Vertical addition, so something like this. See, at any point, C plus I plus G. Okay, so repeat that for every point, you get a point. So if you do it, of course, in your exercises, you do it algebraically. Is that right? Okay, so it would be something like that. So planned expenditure would be C plus I plus G, because I and G are fixed. So planned expenditure has slope of MPC. So this is planned expenditure. Okay, this is what? This is demand for goods. Short run. Demand for goods in short run. Okay. Okay. So let me put planned expenditure here. Let me put planned expenditure here. Okay. What is supply of goods? This is demand for goods. What is supply of goods? Remember, supply of goods is Y. Y is supply of goods. So, in equilibrium, supply of goods and demand for goods or planned expenditure must be equal. So it means this. In equilibrium, planned expenditure is equal to actual expenditure, is equal to income, equal to output. So planned expenditure equal to Y. Now, my question, does anybody know how does planned expenditure equal to Y look like? Anyone? How does this curve look like? Planned expenditure equal Y. Anyone? No? See, planned expenditure is here. Y is here. Planned expenditure equal Y is equal Y. Is this very famous line? You were in high school, you had what? Y equal X. See? Y and X. So Y equal X was what? Was it 45-degree line? 45. So this is what? This is 45-degree line. This is 45-degree line. So in this graph, in goods market short run, 45-degree line behaves like supply of goods. Like that, okay? It's more than that. Supply of goods plus equilibrium conditions. Can you see that? So, look at that. Supply and demand for goods. So this is, guys, this is short run equilibrium in goods market. Port A is representing short run equilibrium in goods market. Did you see that? So it means if your economy is at port E, as long as you haven't touched anything else, it stays there. Is that right? But my question is this. Suppose economy is not at port E. Output is not by the star. Suppose output is equal to Y bar, sorry, Y1. Can you tell me what's going on there, anyone? Anyone? What's going on at Y1? It's not equilibrium, but what's going on? You should have seen this model before. No? Haven't you seen this? You see here? Look at here. You see it? You remember? This is planned expenditure. So if income is this much, demand is this much. But supply is along 45-degree line. This is supply of goods. So you have what? So you have excess demand for goods. So if Y is here, so you have excess demand for goods. So what happens? When you have excess demand for goods, what happens next? Anyone? If demand for goods is more than supply, then what happens? Yes? I was waiting for that answer. You know, but that answer is a classical view answer. But here we are Keynesian. Remember, Keynes said what? Price, okay. Here we, in short, we assume that price is fixed. Okay, so Keynesian answer is what? That was right, classical view. Remember, in classical view, long run price is fully flexible. But this is short run, we are Keynesian, price is fixed. So what happens is, remember, at fixed price, firms sell as much as they can. How much they can sell? You see, this much demand. They satisfy the whole thing, but the difference would be what? The difference is coming out of inventories. Inventories. You see, you remember inventories, guys? I promise you to tell you the function of inventories. So here, firms sell out of inventories. Then when inventories are falling, you know that firms generally keep inventories at certain level. Okay, so what happens? Firms realize that demand is high. When demand is high, firms decide to increase output. Okay, so you can show that mathematically that output goes up and staircase like that. Can you see that? So see, in short run, price mechanism doesn't work. Inventory mechanism is working now. Okay, so of course you know that what happens this side if income is more than equilibrium. So here you have excess supply. So it means firms at that predetermined price level, firms cannot sell enough. Therefore, so inventories capture the difference. Inventories capture the difference. Inventories capture the difference. So, but what happens here? Inventory space is limited. Is that right? You cannot just accumulate them forever. So when your inventories are rising, what do? You have to slow down output. So you see, output is cut. So output is cut. Do you see that? This is how we get to short run equilibrium. Okay, so guys, no price mechanism, inventory mechanism. Okay, so that's why we call change in inventories. Remember, we put change in inventories in investment, unplanned investment. Okay, because they happen, they just happen. So inventories capture the difference between supply and demand. Okay, let's do one little exercise and then we go on. Okay, as usual, you know my favorite. So suppose G goes up. What happens? Graph, guys. You remember part A? Is it the same plan for short run, for the whole course? Anyone? If so, what happens from graphical point of view? No one? No contribution? Yeah. So where is G? G is here. Can you see that? So planned expenditure shifts up. Have you? Planned expenditure shifts up. So as you can see, you go to a new equilibrium. So output rises. Equilibrium output rises. So this is from graphical point of view. From intuition point of view, guys, the same plan. You have to write everything. Government spending goes up. What happens exactly next? Planned expenditure rises. Planned, you remember? G goes up, plant expenditure goes up, and then what happens? You have excess demand for goods. Actually, you can write excess demand for goods, and then inventory levels fall. Is that right? Because firms sell out of the inventories, and then what happens? Firms decide to increase output because inventory levels are shrinking. Okay? When output rises, consumption rises too. Is that right? Because output rises, income rises, and disposable income rises, consumption rises. Okay, let me stop here. And then we keep going next week. Okay? So please, guys, don't fall behind details. See this part in a couple of weeks becomes one whole page of a slide. Okay, so please don't fall behind.